right. So this is work that I've done together with colleagues at Nantes University, and we published this last year in ISWC. So this is FedShop, a benchmark for testing the scalability of SPARQL federation engines. The context here is that we assume we have a federation of data sources, which are RDF data sources, and more precisely, these are SPARQL endpoints. So SPARQL is not only a query language, SPARQL also has a protocol for making available web services via which clients can send their SPARQL queries and get the results. And once you have these SPARQL queries, these SPARQL endpoints, you can basically build a federation where you can virtually integrate multiple graphs and run queries over the virtual union of these. And there has been a lot of work on different such query engines. And just to give you a bit of a more concrete example, there is a benchmark called FedBench, which is kind of the standard benchmark that all these papers use to evaluate the efficiency of their respective query engines. And there's one quickly here. In this FedShop, we have different federation members. Right. That's just yes. All right. So in the FedShop benchmark, there are 11 federation members. They provide access to, for instance, DBpedia and New York Times dataset, some publication dataset, geonames, and so on. And then one of the queries in this benchmark, one here, and basically asks for a list of US presidents, their party membership, and news pages about them. And the federation engine basically gets query that looks like that, which is meant to be evaluated over the virtual union of all the RDF data sets that are in these SPARQL endpoints. And so the first thing that the federation engine has to figure out, it has to basically decompose the query and do source selection to essentially understand which parts of the query can be answered based by which of the federation members. And then how to do the joins between these different subqueries. Okay, so, and then they execute this and then they get the result. Now, in this FedBench, like I said, there are 11 federation members. The question that we are asking in this work is what happens if the size of this federation increases? There's no work that basically studies the scalability of these engines in terms of increasing number of federation members. That's essentially what we wanted to do to build a benchmark. And we call this benchmark FedShop. The idea of the benchmark is that we simulate a federated e-commerce scenario with a federation of shops and a federation of revenue sites. And then you have basically kind of simulate the user which kind of browses the shop, tries to find products, given some features, tries to retrieve information about these products, tries to compare these products, and so on. For those of you who know the Berlin SPARQL benchmark is basically kind of the same type of use case, only that in this benchmark we do it on federation. Okay. I will tell you a bit about the data sets, about the data that we have in this federation, about the queries, and about something that we call the RSA queries. We'll come to that. Let's begin with the data. So we consider a virtual catalog of products and producers and so on. Virtual here means that this product catalog is not really materialized, but all shops basically provide access to products or data about products that are in this virtual catalog. Each of the vendors sells some of these products that are in this virtual catalog, and each of the vendors is autonomous, which basically means they can operate independently from one another. And therefore, all the UIs that they use locally in their data sets, they need to be local UIs, so that you can retrieve these UIs based on the data. Here we have the schema of the benchmarks. There's there are the relevant types of entities that are in the virtual catalog with product producers, product types. This is very similar to what is in the Berlin SPARQL benchmark. Then we have each of the vendors, which has offers and data about themselves, and then there are reviewing sites which has reviews persons and data about themselves. And if the shop or if multiple shops basically sell the same product, then this would look like this. In the virtual catalog, we have data about the product using some global UI that identifies the product, and the global UI that identifies the producer and so on. But since these shops need to be independent from one another and need to be autonomous, basically kind of replicate part of this data using their own local UIs. Okay? And then in the data of each of these vendors, we also have same as links to establish kind of the connection on the global level. Okay? And therefore, when we do queries over multiple shops, the joins we then always happen via the same as links and the identifiers for the products and for the producers. Okay. For our experiments, we generated a virtual catalog of 200,000 products. We have 10 different federations, where in the first one we create 10 shops and 10 rating sites. In the next one, we use these 10 shops and 10 rating sites and create another 10 and another 10. And then we keep doing this until we have a federation with overall 200 federation members, where 100 of them are shops and 100 rating sites. And this is kind of the data size of the different setups. So in the biggest federation, we have an overall of 43,000 triples distributed across these 200 federation members. All right, so that's for the data. For the queries now, we simply adopt the use case of the BSDM benchmark, which has 12 query templates, which kind of simulate, as I said, what a user would do in kind of explore in this federated shop. However, we have to rewrite these query templates in order to kind of take into account the same as links that I mentioned earlier to do the joins across the federation members and so on. So if, for instance, in the query in the original product type and then the product type, now the product type would be, we have the global UI, which is in the virtual catalog, and then each of the shops has their own local UI. So therefore, in order to do these queries over the federation, you need to kind of rewrite this triplet pattern into two triplet patterns, which here use the same as link in order to kind of do the join over the global identifier. So we instantiate each of these 12 templates 10 times into 10 different queries. We make sure that these queries produce non-empty results. We make sure that these queries are duplicate free, so we really have 10 different ones for each template. This gives us an overall of 120 queries. And we also observe that for each of these queries, the result size increases with an increasing number of federation units. Now, what are these RSA queries? Basically, we also want to understand whether this FedShop use case is actually realizable. Can we actually, is there a way to execute these queries in a kind of ideal, by an ideal federation engine that figures out the source selection in an optimal way and basically can execute these queries in a few seconds. So in order to test this, we create source assignments manually. This would be kind of the output of the source selection and query decomposition step of a federation engine. We basically manually create these queries that you've seen in the earlier example with the service class. And if these reference source assignment queries can be executed within a few seconds, then we would basically say, okay, this shows that the FedShop use case is realized. In a bit more detail, what we do when we create these reference source assignments, we decompose the query based on the global and the local join variables. The global join variables are the ones where the join needs to happen across federation members. And the local join variables are the variables where the join can happen within the federation. And since we know how the federation is set up and how the data is distributed, for our queries, we know exactly which of the variables are the global join variables. And in particular, these are the variables that are kind of in these, same as triple patterns in the object position of them. And that really basically comes from the fact how we have distributed. So in this example query, for instance, we have just one global join variable, namely this product feature. And therefore, we can basically split the query into the two parts that are connected via this join variable. And then we have kind of a query that we can now run over the federation to figure out in which federation member we get matches for this part of the query, in which federation engine member we get matches for this query, and then we can also see which of them will join with one another. And we do this for all our queries, and then basically see which of the federation members can be used to really produce non-empty results in the joins. Okay, so this is something which we do in an offline phase. And this basically tells us this is kind of, in a way, the ideal source assignment. Okay? And we can do that manually because we know how the federation is set up. Okay. So now we did a study with this benchmark, and what we wanted to see in the study is, first, again, we want to figure out whether this benchmark can actually, or the use case can actually be realized. Then these reference source assignments were executed in a few seconds. And then, of course, we want to compare the different engines. How do they compare to the baseline? And how do they compare to one another? And how do they use them? We set up the benchmark on a single virtuoso server, which serves all the different federation members as separate endpoints. We tested with 4 federation engines, and we generated all the different source assignments for all our queries. We measure execution time. We take timeouts into account of 2 minutes. So every engine that doesn't finish a query within 2 minutes, we kind of time out and then just calculate 2 minutes as the execution time. So here you see the measurements for the reference source assignments. This is the average execution time for all 120 queries within each of the federations. And you see in the biggest federation, we have an average execution time of less than 400 milliseconds, which means that indeed these queries can be executed in reasonable time, if you know what the ideal source assignment is. We also look at each of the query templates separately, and then you see that for some of the templates, they can actually be executed much faster. And almost all is under 2 seconds. That's our baseline. And then we look at the different federation engines that we have tested this with. And you notice that for the smallest federations, still only many of the engines time out many of the queries. They are not even able to do the source assignment correctly or efficiently for Federation 20 endpoints. Only it manages to do it for the smaller federation, but then for the bigger federation, all of the engines basically time out for many of the queries. And then this is the last chart that I have for you, which basically shows the execution time. This is our kind of baseline to be able to run the queries within 2 seconds. And you see that all the federation engines basically they fail to do this thing. So the takeaway here is that we have a benchmark for which we know that federation engines should be able to run this benchmark in reasonable time, but the existing engines just cannot do it. Therefore, the message is that we need more research to really also solve this benchmark. That's my talk.